Welcome back to lesson 8.4. So now we are given an equation of a quadratic. It's in the vertex form, and our task is to go ahead and graph it. So using the vertex and the axis of symmetry and A, we should be able to have some real good clues as to what our parabola should look like. The first thing we can do, just to help us get started, when we're tired, we need a jumping off point, is to write down what the vertex form is for any parabola. A times x minus h squared plus k. So that's not new at this point at all. It's just really helpful to have it. And then we can go and grab our vertex. So the vertex, we remember, is the coordinate point h and k. What's your vertex for this equation? H is 1 and k is 2. Remember, your h is opposite of the sign in the equation. So this was minus 1. So our h will be a positive 1. Now in this graph, our scale is going by 2's. We have a 0, a 4, and an 8. So that must be worth 2 right here. This must be 6. And then vertically, we see the same pattern of behavior, 0, 4, 8, and 12. So we can mark that really carefully just to help us not make mistakes as we graph. So my coordinate point is 1, 2. So we'll go to the right, 1. Yeah, that's in the middle. That's weird. And up 2. So it appears to only go up 1 unit, but we remember because of our scale, that's not what's actually happening. Okay, let's write vertex. We know our axis of symmetry, AOS, is x equals whatever the h is in our equation. H is 1. Wasn't that fast? And there it is, drawn on your paper. Let's see some new things. A. What is the value of A in this equation? That's right, A is 8. Is that positive or a negative 8? Yep, it's a positive 8. And when it's a positive 8, that means that our parabola will open, that's right, you remembered, upward. Good. So we have seen that a graph, a parabola, one step out from the vertex goes up 1 unit, or whatever it is, A, times 1 unit. So 8 times 1 is just 8 up from the vertex for my next coordinate point. Let's see how that works. So I'd come over a unit, and let's go up 8. 2, 4, 6, 8. Wow, this is tall and skinny. Don't I wish I was tall and skinny? Let's go to the left, 1 unit, and go up 8. 2, 4, 6, 8. There we go. I didn't even have to draw our t-table, so we're getting some new skills. All right, so now it's your turn. I want you to try problem number 5 right next door. If you get stuck, come and ask me. If you finish it, I will be happy to check it. Pause the video and then we'll work through number 13. Problem 13. In this problem, you've been given a description of 2 points that will be in our quadratic function, and we need to rewrite this function in both vertex form and in standard form. All right, so we've had a little bit of practice with this before in problem 3. I'm going to get you started, and then you're going to have to finish it on your own because this one starts off differently. So let's have a quick reminder. Let's write on our paper. For the vertex form, f of x is equal to a times x minus h squared plus k. For the standard form, f of x is equal to ax squared plus bx plus c. There it is. All right, let's look and see what they gave us in the problem. The first thing they gave us is the vertex. So this is H. Let's label it as H. And this is K. Let's label it K. That's important. The second thing that they gave us is a random coordinate point that the curve passes through. Well, up until your lessons with quadratic functions, you said that all coordinate points were x and y. And now we have this new coordinate point that's h and k. Well, that's only for the vertex when you get an h and a k. So all other coordinate points, x and y. So now that I've labeled it, let's go back and look at our two functions so that we can figure out where to start. Vertex form, standard form. Which one of those two forms has an h, a k, an x, and a y? You might say, I don't see a y on either of them, so I don't know what to tell you about that. Yes, you do. You remember that f of x is the same way to write y? Oh, yeah, it is. So which one of these two forms has an h, a k, an x, and a y? That's true. It's your vertex form. So this is the form that we're going to start with. We're going to fill in the blank because the piece that we do not have is a. We have to go get that. As soon as we get a, this is going to wrap up just like we did number 3, because we did number 3, the whole thing together. So let's rewrite our function to tell us how to get started. F of x equals a x minus h squared plus k. All right, let's fill in the blanks. What's going in for f of x? Y. Yeah. So of my two coordinate points, here they are, which number is in the y location? Oh, there it is. Whoa, 635. That's huge. That's okay. You have a calculator and a good brain. 635 equals a. We don't have anything labeled for a. Nothing at all. But I do have an x, What's the value of x in my two coordinate points? There it is. There's my x. It has a value of 6. Minus h. What's in the h location? -2. Make sure you put both of these minuses in there. That's really important. Squared plus k. What's the value of k? Yeah, it's -5. All right, let's start cleaning things up and see if we can solve for a. Draw the river through your equal sign, just to keep things separated left and right. 635 equals a times. What's a minus and a minus side by side? That's right, it's a plus. And what's a plus and a minus side by side? Good job, you remembered. It's a minus. Order of operations. Well, we can add the 5 over so my 5's on the right cancel, and on the left, 635 plus 5, that's going to make 640. Great. What do we do now? Do you add first because it's inside of the parentheses, or do you do the exponents first? Yeah, you do what's inside of the parentheses first. That's right. So 6 plus 2 is 8. What do we do now? Square the 8. This is becoming real clear of what we need to do. 8 squared is 64. And last but not least, how do you get rid of that 64? Do you remember? Do you subtract it? No, I don't think you subtract it. You have to divide it. Let's do that. What you do on one side, yeah, you do to the other. The 64s cancel. What's 640 divided by 64? Good job. It's 10. Whew. We have now finally found A. That took some work, didn't it? But you did it. Nice job. That was the hardest part. It really was. I wish I could say we're done, but we're not. So this is what has to happen now. Let's write our actual full function in vertex form. And I'll start again with the generic vertex form. F of x equals a times x minus h squared plus k. So I just want the equation, and whenever I'm writing an equation, the f of x, it stays put. Does not turn into a number. It's just if I need to go solve it that it might turn into a number. I know what a is now. We just solved for it. What was a? Just did all that work. There it is. It's 10. Parentheses. So again, I'm just writing out my generic equation. So you always have an f of x or a y and an x minus my h. What's the h value? Do you remember? There it is, -2. Plus k. What's your k value? Here it is, -5. All right, let's clean this up. F of x equals 10 times x. What's a minus and a minus side by side? Yep, plus 2 squared. And what's a plus and a minus side by side? That's right, -5. Okay. This is the vertex form. Let's label that. All right, this is where it's your turn, a lot. So here you are instructed that you still have to write this in standard form. So you're going to take your vertex form and you're going to expand it. So just like we did in problem number 3, you are going to do this part of the work to expand this into standard form, just like problem 3. Okay? So now you know your task. Pause the video and come and ask me if you need some help. Problem 15. We're going to start this problem together, and then I'm going to let you finish it on your own. So here they gave us a graph. They want this written in vertex form and standard form. But they didn't even give us any coordinate points this time. What are they thinking? They're thinking that you have some skills that we need to put to work. So we saw on problem 13 that in order to start writing an equation, I need a vertex and a coordinate point. So let's write that out. Need a vertex, and I just need a point that our curve passes through. Okay. Well, let's look at your picture. Vertex, vertex, vertex. There's the vertex. It's at the very top. We'll label it. There's your vertex. Hey, what's the address of that coordinate point? Left, 1, 2, 3, -3. Up, 1, 2, 3, 4. 4. That is the address of my vertex. This is H and K. All right, that wasn't so bad. Now let's find a nice clean point that our curve passes through. So here's a nice point. We can use it. We could have used several points. That's a clean point. See how that's in between the two vertical lines? That's why I wouldn't use it, because I don't know where it is between them. So it's not a, quote, clean point. It's not a technical term, just a user-friendly term. This is a clean point. It's right there on the cross. It's just in the X. And then finally, I have another nice clean point. So any of these 3 points Actually, here's a fourth and there's a fifth. There are 5 points I could choose to work with. Oh, why don't we just use this one? It's friendly. So a clean point, this second one right here, we'll use it. We'll put a big X, a big star on it to say that's what I used. Left 1, up nothing, up 0. That is my X and my Y. All right, now it's your turn. So you have to use the vertex form of your equation. Whoops, A times x minus h squared plus k to plug in your 4 numbers, the ones that we just got from our 2 coordinate points. Go solve for your vertex form of the, go solve for A. Use A and your vertex to write the vertex form of the equation, just like we did in number 13. And then expand that out to get the standard form, just like you were supposed to do in 13 and we did do in problem number 3. If you get stuck, come and talk to me.